So this is the new chapter for electrochemistry. I'm starting with the first subtopic, which is 3.1 Galvanic cell. So in this subtopic, we are going to learn the introduction to electrochemistry. We have the redox reaction. So in redox reaction, we have two main processes. The first one is oxidation and the second one is reduction. So for oxidation, a process where atoms, molecules, or ions gains oxygen. So I'm going to put it as gains oxygen, but this oxidation process will loses hydrogen, loses electrons, and the last one, it will have increase in oxidation number. So the substance that undergo oxidation is what we call as reducing agent, the opposite to the name of the process. So the second process is going to be the opposite of oxidation. It is a process where atoms, molecules, or ions loses oxygen, but it will gains the hydrogen and electrons, and the oxidation number will decrease. So the substance that undergoes reduction is what we call as oxidizing agent. So this term is very important for you to understand, and I hope you can also use the simple acronym to understand more. For example, I have NOx. N is anode, ox is oxidation. So oxidation will happen at anode. So oxidation is loss. Next, we have REDCAT. This acronym is helpful to determine the position of reduction, which will be at cathode. Reduction is gaining. So losing the electron, gaining the electron. So I hope you can understand the two differences here. Next, we are going to learn more about the component of galvanic cell. The other name is voltaic cell. So let's focus more about this part. So in our setup, we will have a half cell for each of the electrolyte. So in half cell, you have electrode immersed in electrolyte. Electrolyte can be any aqueous solution that you can found during the experiment. And when you want to set up, the more electropositive metal will be our anode. So in this galvanic cell, anode will be our negative electrode. However, for positive electrode, we call it as cathode. And cathode must be made up of less electropositive metals. Next, in our setup of galvanic cell, we need a salt bridge. So what is the salt bridge? It is an inverted U-tube that contains a gel permeated with solution of inert electrolyte, such as we have KCl, the common one. We also have sodium sulfate. It can be also NH4NO3 or KNO3. So the function of our salt bridge is to separate between the two electrolytes. And then the second function is to maintain the electrical neutrality or ionic balance by allowing the ions to move between two electrolytes. So you can see the ions we are talking here is based on what you have in the electrolyte, either positive or negative ions. So this is the setup for our example of electrochemical cell. You can see this is our salt bridge containing inert electrolyte, which is KCl. And then our zinc is our anode and copper is our cathode. So you can understand here, zinc is more electropositive than copper. Next, we focus about this part. In galvanic cell, we also have voltmeter because the other name of galvanic cell is voltaic cell. So it must have voltmeter as a reader for our value that we want to record. So, as I mentioned before, based on this example, zinc is more electropositive than copper. So, the tendency for zinc to release the electron is much more easier compared to copper. So, here you can see zinc electrode is our anode. So, this is our negative terminal. Another name that you can understand. And cathode is our positive terminal. This is the setup for galvanic cell. This solution, zinc sulfate, is our electrolyte, and also same goes for copper sulfate. And last one, don't forget the salt bridge in the middle of two electrolytes. So how the process happen here? This process will undergo redox process, which is we have two sides. The first one is anode, the second one is cathode. I did mention for anode, you must remember the acronym, which is NOx. Jadi oxidation occurs. So write it down. So how to write the half equation for this one? You have to understand anode is the process where oxidation is losing the electron. So electron must be at your product side. How to write the equation? We are starting with the electrode itself. So this electrode at anode is our zinc. So I'm starting with zinc solid. Don't forget the phase. And to produce zinc 2 plus, this is aqueous plus 2 electron because oxidation is losing the electron. So you can write the second point, zinc loses electron. And then what about the oxidation number of zinc? You can see that starting from 0 oxidation number for Zn solid, it will be positive 2 for zinc ion. Jadi oxidation number increases from 0 to positive 2. So how about the observation happen here? The observation that you can see, our zinc electrode will dissolve. Next, let's go for cathode. For cathode, our electrode is copper. So copper for the cathode is the reduction process. Reduction is gaining, oil red. Ini adalah akronim yang kita pakai. Okay, reduction is gaining. Jadi bila gaining, kita akan mulakan dengan charge dahulu. Jadi charge kita adalah Cu2 plus aqueous. Reduction is gaining electron 2 of it. And then you will produce copper solid. So here reduction occurs. And then the copper gains electrons, where the oxidation number of copper here starting from positive 2, it becomes 0. So the oxidation number of copper decreases starting from positive 2 to 0. The observation that we can see is the copper electrode, we have a specific color for that, which is reddish brown solid. So the reddish brown solid is deposited in this electrolyte as your observation. So now, continuing from there, I'm going to write the half equations and overall equations for this electrochemical cell. Starting with zinc, our anode. So I'm starting with Zn solid, produce Zn2 plus aqueous plus 2 electrons. And then for the copper, we are starting with Cu2 plus aqueous plus 2 electrons to produce Cu solid. So you can see the number of electrons are the same. So I'm just going to cancel out both of it. So the remaining will be our overall equation. So just copy back at the reactant side. So zinc solid plus Cu2 plus aqueous. And then it will produce Zn2 plus aqueous plus Cu solid. So this is very simple. You have to make sure that the number of electron will be the same before you cancelling out both opposite sides. So now I'm going to explain about how the salt bridge works in electrochemical cells. First thing first, we copy back the half equation that happened at anode and cathode. So here, if I zoom in this picture, so I'm going to explain the process happen here. So first thing first, based on the half equation, you're starting with the zinc electrode itself. This is zinc solid, referring to the zinc electrode. Zinc electrode, what happened once you give the power supply to the voltmeter, and then the ions from zinc electrode will release. So you will have zinc 2 plus as your product. That's why half equation, these zinc ions berada dekat bahagian produk. Then these ions will enter the solution. So this solution, originally we have zinc 2 plus and SO4 2 minus in our electrolyte. Jadi, bila kita tambah lagi zinc 2 plus daripada electrode, jadi banyak zinc 2 plus dekat sini. So it will cause the overall excess of positive charge. So sebab tu kat sini, bila ada banyak positive charge, the function of salt bridge, for example, our salt bridge use the inert electrolyte such as KCl. So dalam KCl, kita ada K plus dan Cl minus. So ini ion yang ada dalam salt bridge. Jadi because of positive overall charge at the anode, so it will neutralize by taking out the negative ions from salt bridge. Jadi Cl minus ions akan masuk daripada salt bridge ke dalam zinc half cell untuk neutralize the overall positive charge. Okay, so I put it Cl minus. So the process happen, akan ada electron flow. Electron flow from anode to cathode. So, once sampai dekat cathode, apa yang terjadi dekat copper electrode kat sini, kita memang sudah ada Cu2+. Tapi elektron masuk menyebabkan Cu2+ ions leaves the solution. So, elektron masuk banyak ni kan. Jadi, elektron negative charge. Cu2+ positive charge. Jadi, tak kena. So, Cu2+ mengalah, dia leaves the solution. Bila dia leaves the solution, kan awal-awal solution ini adalah CuSO4. Kita ada Cu2 plus dengan SO4 2 minus. Jadi bila elektron masuk, jadi elektron pun negative charge. Jadi banyak negative charge kat sini menyebabkan overall excess of negative charge. Because Cu2 plus leaving. Cu2 plus keluar. Jadi akan ada overall excess of negative charge here dekat bahagian copper half cell. So bila copper half cell ada overall negative charge due to the electron dan juga SO4 2 minus, jadi ion yang akan datang daripada salt bridge adalah positive ion, which is in this case adalah K plus ion. So this K plus ion will neutralize the excess SO4 2 minus yang tidak perlu pun dalam electrochemical cell because this is our spectator ion. Jadi nak neutralize, kita ambil positive charge daripada salt bridge electrolyte. So this is how the salt bridge works in galvanic cell ataupun voltaic cell. So now for this video, you've learned what is galvanic cell, and we have two main processes, oxidation and reduction. Remember acronym OIL-REG. Oxidation is losing electron, reduction is gaining the electron. Satu lagi akronim NOx dengan REDCap. Anode will undergo oxidation, cathode will undergo reduction. And then you juga belajar cara untuk tulis half equation dan juga overall equation dengan syarat you cancel out the electron. Seterusnya, kita jumpa dalam next video. See you. Bye.